What is up, everybody? Welcome back to our weekly live stream from Scalar Learning. And today we are continuing with the Khan Academy SAT problems. As everything is now getting set up, I'm just making sure my technology is going and the live stream is indeed running. We need a quick sound check over here. It's looking like we are good. We can hear. All right, sweet, sweet. Let's get right into it. Oh, go back here. Make sure my live stream, I didn't get a notification. Let me just make totally certain. This has happened before where I believe it's running. I do the whole thing. Nah, it's happening. All right. Here it is. Yeah. All right, sweet. Let's begin. And today we are doing interpreting nonlinear expressions. Nonlinear expressions. Difference between an expression and the difference between an expression and an equation is an expression has essentially expression has no equal sign and the equation has equal sign. So that is the difference. Let's jump into it. As always, I'm seeing these problems for the first time, and that is always part of the fun. All right, let's get into it. The amount of water vapor in grams that will saturate 1 kilogram of dry air when the temperature is X degrees Celsius is approximated by this guy. Actually, this is an equation, not an expression, but that's okay. For each increase of 1 degree, so every time, so this is again degrees up here. For each increase of 1 degree, what is the percent increase in the amount of water vapor required to saturate the air according to this model? So it looks like what's happening in terms of the percent, so they want the percentage. So I'm saying that every time this goes up by 1, it looks like this is going up by 7% because it's kind of like this. This is, if we're multiplying something by 1.07, we're increasing it by 7%. And then when we multiply it by 1.07 to the second power, we're increasing that value, that old value, by 7%. So it's like if it starts at 100, then it goes to 107. It doesn't go to 114. It goes to 7% added on of this, which would be 7. Hold on, let's see. Let's just do it really quickly. 49, 4, and 7. So 7.49. So it'd be 114.49, if that makes sense. So you see what's happening here? So essentially, but I mean, I can tell from this equation, basically, it looks like this should be a 7% increase for every 1 kilogram that this guy goes up. And yes, that's correct. And they sort of do a little example here, playing it out, right? When it's to the 0th power, it's just what it currently is at. When it's at 1, that's a 7% increase. At 2, that's a 7% increase, and then a subsequent 7% increase after that. So that's basically it. Let's move on to question number 2, non-calculator. The administrators of a factory modeled the cumulative average construction time in minutes. Always gotta pay attention a lot more with these word problems. So I'm going to start over. The administrators of a factory modeled the cumulative average construction time in minutes per engine, I'll say component, as a function of the total number of components their employees had constructed. So this is total components over here, number of components, equals 3.5 plus 7 times 0.9, and then what's to the n power as a function of the total. The average construction. So this is minutes. This is time in minutes, and this over here is number of components. I'm not going to use n. I'm just going to try and use that instead. So now we can understand what's going on here. So the total time, the average construction time is, average, right? Average construction time is equal to this whole equation. All right, I think I get that. and I think what's going on here is, so let's see, 0.9. All right, so what's going on here, if you pay attention, is this average time should actually be going down as the number of components goes up. Because we're talking about average. It's basically, it seems as though the more they do it, the faster they get is, I think, the implication. And why do I know that? Because we have a number between 0 and 1, that 0.9, that's being raised to an exponent. So this number should be getting smaller and smaller. Essentially, it should be approaching 3.5 when you have like an infinite number of components. The fastest they'll get is 3.5 minutes per piece. What was the cumulative average time for an employee to construct one engine component when they first began? So when they first begin, that n would be 0. Right? 7 times 0.9 to the 0th power, which is, this is just 1. Anything to the 0th power is 1. So it's 3.5 plus 7, which should be 10.5. And this is a non-calculator section. You don't need a calculator for this, as you can see. Let's see if that's right. 10.5. And it is correct. Let's go on to the next. Oh, boy. This is intense. This a lot of times are actually easier when they have crazy graphs like this that look intimidating. So we have our equation, which is nice. R equals 0.5 times 1.2 to the theta. A certain type of mollusk has a shell in the shape of a spiral as shown below. The distance r, this guy, from the origin to a point on the spiral, so from the origin to a point on the spiral is r, is modeled by the equation above, so that's what this is. And where theta is the angle, so theta is what angle radians measured counterclockwise from the positive x-axis, and that's counterclockwise like this. So in this case here, like I'll take this example, this theta is probably, if it were in degrees, it'd be like 60 degrees. In radians, it would be like pi thirds or something. Okay, what is the best description of 0.5 in the formula? So it doesn't, none of that matters about radians or anything like that. So what is 0.5? My guess is 0.5 is the radius right when theta is 0. So it's basically, if we go straight out here, I think that's 0.5, this little tiny value in there, because again, that's when we're talking, when the 0.5, we'll see really what the 0.5 is when this value goes to 0, because then it'll be 0.5 to the 1.2 to the 0 power. This is 1, so this goes away. And guess what? That's the radius, that's the value of the radius when theta equals 0. I think that's what their answer is going to be, something like that. It's not a rate. It's no rate of increase or anything, because it's just some constant. It's the ratio of the radii that differs by 2 pi radians. That's not really making sense to me. Okay, this one is, it's the unit, is the unit length, this is it. Is the unit length of the radius corresponding to theta equals 0? Yes, that's what it is. This one I don't even understand. This one won't be right, because if we plug 2 pi in, we'll clearly get something else. Because it'll be 1.2 to the 2 pi, which is like the 6th power, and then it'll be a much bigger number. So this should be correct, and it's correct. All right. You can see these problems are hard. They're not that bad once you break down the language, but they can seem really hard and really confusing. According to Bernoulli's equation below, the product of the area A1, this is this guy, of the cross-section of a hose, so I guess a cross-section of a hose would be like this, at a particular point, and the velocity, so this is A1, I guess, that area, and the velocity of water traveling through the hose at that point, so let's say this is our water and whatever, V1, will be equal to the product of the area A2 of a second cross-section. You don't really need to draw this out. I'm just doing it to visualize and to show you as I'm figuring out what they're asking. The same hose is second point, and the velocity V2, like this, of water traveling through the hose at the second point. So they're saying these two are always going to be equal. Is that what? I guess that's what they're saying. You choose 2 points. This is like if we had a hose like this. Let's make our hose green. If we had a hose like this, they're saying that the cross section here maybe is A1 and here is A2. And then if we take A1 times V1 at that point, multiply them, it would be equal to A2 times V2 over here. So I guess it's always equal. If someone covers 1/4 of the opening of a hose, how will the velocity of the water coming out of the hose change? Interesting. So 1/4 and 1/4. I don't know if it's 1/4 of the opening of a hose. How it change water coming out of the hose? Okay, let me think about that. So then they're saying here's A1 in their example, and then here's A2. So they haven't changed A2. So basically A1 is going down by 1/4. So now it's like if the two were equal to each other, I can just pick numbers. I think I get what they're saying. It's like 3/4 times, I don't know, I'm just gonna choose 100 for V1 and then so it's, and I'll just choose 1 for A1. So it'd be 3/4 times 100 equals, and then let's pretend the original value was also 100 over here, because okay, what I'm trying to say is this was originally our original values. Let's say it was 1 times 100 equals 2 times 50. I don't know, I'm just making it up. So this is my area, this is my A2, this is my A1, this is V2 and V1. So now I'm taking 1/4 away, so I'm making it like this, but then these two guys still have to be equal to each other. And I'm not changing my area in the back. They're already saying that the area's not changing, so obviously the velocity has to change. So in order for this to be true, what does this value have to become? It was 2, but 2 won't work. So it's basically what times 50 is going to give you whatever this is, and this is going to be 75. So what times 50? That would actually be 3/2. And you could isolate this. You could put an x here and calculate it, but I can tell you that I know 1.5 times 50 is 75. So what is happening? The velocity is dropping from 2 to 3/2. So the velocity also has to shift down by 1/4. Will be, so it doesn't drop to 1/4, it drops down by 1/4. So the velocity of the water will be 1/4. No, that's not true. It won't be 1/4, it will be 3/4. Velocity of water through will be 3/4 of the velocity through the full opening. Yes? No? So if I did this correctly, which I'm pretty sure I did, this should be right. I'm wondering if now it's making me think that it should be 4/3 because I just see that after, but that wouldn't make sense. I believe I've done all this math correctly, so let's check it out. It's wrong. It is 4/3. Okay, so let's actually understand why, because let's see. Let me see if I can figure it out first. 3/4, and that drops by 3/4. So the area, I dropped the velocity. So the velocity was 1. I should drop the area to 75, but it still would have been the same result. And then that should still be 75. 2 times 50. Okay, let's understand. Let's read this and figure out why. So it is 4/3. Someone covers 1/4 the opening, and then 3/4 open remains. Let's use the expression 3/4 A, right? So then we substitute into our formula in place for A2. See, that doesn't exactly make sense to me, because why are they substituting? We need to know what the area for V2 hasn't changed. then they're saying we solve for V2. So this area has dropped. Like this I agree with. So, but see, I would have put it in here. 3/4 A. 3/4 A1 V1 equals area, and then V2 has to go up. But this area hasn't changed. See, this is throwing me for a loop. I'm going to have to really... This makes sense because you'd think if you cover up part of it, it would go fast. No, you know what? All right. I am actually... This is I think the first one. I've gotten answers wrong before, but this is the first one that I'm just not seeing exactly their reasoning. So I'm going to have to think about this a little bit more. Please leave a comment below if you also have a question on this question, or if you want to see me go back over it again, because I'm a little bit perplexed. I don't know why all of a sudden as I was choosing the answer, the 4/3 seemed to make more sense to me, but anyways, yeah. So I'm gonna let me think about this a little bit more. All right, sorry about that, guys. Let's go on to question number 5. Hopefully this one I can actually get right. Now we got biologists stocked a lake with a new species of fish. The number of new species of fish in the lake, PT. So PT is new species. New species. And T is years. Oops, 1.5 T. Sorry, not 5, T. And this is years. After being stocked is shown above. How many fish did the biologists initially add to the lake? So again, T, we can tell that this is going up. They don't even care. We don't care about any of that. When they say initially added to the lake, that means we want to know at time equals 0. That's initially. And that's when time equals 0, that's 1.5 to the 0 power, which is just 1. And our value is this. Our value ends up being 400. That's what they started with. So this should be our correct answer. Let's give it a shot. And that is correct. All right. There we have it. So those are the interpreting nonlinear expressions. Very challenging problems. And again, like I said, if you are also confused by 4, leave a comment below or ask me a question, shoot me an email, whatever you like. I'm going to actually think about it a little bit today, and if I do figure it out, or if I somehow, whatever conclusion I come to, I'll be happy to share it if you guys want to hear it. So let me know, and please subscribe if you haven't done so yet. We got live streams coming out every week on Wednesday for your SAT-related content, math content. But we also have a lot of other really cool content. I got lots of math music videos, a new one coming out anytime now, a rap song. I kind of rapped it on Instagram the other day on a Instagram live feed, which was really fun. So that's going to be coming out soon. We got some really cool stuff that I've been working on with my math class at school, Jeopardy video that's coming out shortly. So anyways, if you guys like what you see, please subscribe, leave comments. Definitely like this if you find it helpful or useful in any way. Thank you guys so much, and have an awesome rest of your day and rest of your week. Take it easy.